This is question 3 from the November 2018 Standard Level Mathematics E-assessment for MYP. We've got a diagram which has 3 triangles, and we're told that some of these angles are 90 degrees, specifically ABC, ACD, and ADE. And we're given these sides 9, 12, and 20. And the first thing we have to do is to determine the length of AC. So I can see that AC is part of this triangle, and I've got 2 of the sides, so I'm going to use Pythagoras. Okay, so here is my triangle A, B, and C. We're given the 2 sides, and this is the side that I want to work out, AC. And using Pythagoras' theorem, which is given to you in the formula booklet, so you don't need to remember it. And if we scroll through, here it is on page 6, Pythagoras' theorem. The longest side squared is equal to the shorter side squared plus the other shorter side squared. So if we go back to our question, we've got the longer side, which is AC, which is what we want to find out. So AC squared equals 9 squared plus 12 squared. We can put this straight into our calculator. Nine squared plus 12 squared equals 225. And then, of course, you need to square root your answer. Not like that, though. Come on. Square root your answer. There we go, which is 15. So these both equal 225. Square root our answer of 225. SC equals 15. Okay, let's see what question B is. Okay, so part B is hence show that the length of AD is 10 root 3. So I've just gone on to another page to make it easier to see. We've already worked out that AC is 15, so I'll put that in. We need to show that the length of AD, which is this length, is 10 root 3. Okay, so I'm going to deal with this triangle now, because I've got this side of the triangle, I've got this angle, so I can use trigonometry. So in order to use trigonometry, I'm going to label my triangle. So I've just taken this ACD and drawn it out. This is what we want to show, is 10 root 3. So I'm going to label it. So here's my right angle triangle. So this means that opposite side to my right angle triangle is my hypotenuse. Opposite side to my given angle is the opposite. And my side left over is the adjacent. So I know the adjacent, and the hypotenuse is the one I want to work out. So it's thinking of our SOHCAHTOA. I know the adjacent. Hypotenuse is what I want to work out. So I'm going to use K or cos. And the formula, again, is given to you in the formula booklet. So we scroll over. Cos is equal to adjacent over hypotenuse. So cos of the angle. So cos of the angle, which is 30, is equal to adjacent over hypotenuse. So cos of 30, let's just put the numbers in, is equal to adjacent, which is 15, over hypotenuse, which is what we want to work out, which is AD. Now, in order to find out what AD is, I'm going to need to rearrange this. Now, probably, well, there's different ways you can rearrange this. You may be able to do it in one step. But just to show you one particular way, in order to get AD by itself, now AD is part of this fraction. So in order to I suppose, get rid of the fraction, if I multiply both sides by AD, then on the left-hand side, I get AD times cos 30. And on the right-hand side, because I'm multiplying by AD, it eliminates the fraction, and I'm just left with 15. And then to get AD by itself, I need to divide both sides by cos 30, because the cos 30 is multiplying by the AD. And that gives me AD equals 15 divided by cos 30. Now, unfortunately, you cannot just put this into your calculator. If I put in 15 divided by cos 30, you get 17.32, which is the correct answer, but they want it as an exact value. They want it as 10 root 3. So I need to work out what cos of 30 is exactly, and you work this out from using your exact values. Okay, so you may remember there's specific ways to work out values of cos, sine, and tan of 30 degrees, or 45 degrees, or 60 degrees. And the way that we work these out, so cos, sine, or tan of any of these angles, we use right angle triangles. So hopefully this will serve your memory well. So the first triangle I'm going to draw, two triangles, so I'll draw the first one first. And the first one is a 1, 1, root 2, so it's an isosceles triangle. And if it's isosceles, it means that, well, these two sides are the same, which they are. And if this is 90, then these two angles have to be 45, because they must be the same, and 45 and 45 is 90. So this enables me to work out sine, cos, or tan of 45 degrees. So for example, sine of 45 is equal to opposite. So sine of 45 is opposite, which is 1, over hypotenuse, which is root 2. And cos of 45 would also be the same. Cos of 45 would be adjacent over hypotenuse, which would be 1 over root 2. Tan of 45 would be opposite over adjacent, which would be 1 over 1, which is 1. So that's the first triangle that you need to remember. The other one, which is going to be relevant to this question, is like so. Now you can either remember all these specific values, but I find if you just remember these triangles, it makes it a lot easier. So this side is 1, this side is 2, and this side is root 3. Got 60 degrees and 30 degrees. So this enables us to work out cos, sine, or tan of either 30 degrees or 60 degrees. So for example, if I want cos of 60 degrees, cos of 30 degrees, because let's do that one because that's what's in our question. So let's go to 30. Cos is adjacent over hypotenuse. This is opposite, so adjacent is root 3 divided by, so root 3 divided by hypotenuse. Here's my hypotenuse, which is root 2. So cos of 30 is root 3 over 2. Similarly, if I wanted, let's do sine of 30. Sine of 30 is opposite over hypotenuse, 1 over 2. Okay, so make sure that you remember these triangles. how to use them. They're very, very, very important, especially when you get to diploma level, because you will need them quite a lot then. Okay, so I'll just put that in a little box as a reminder. So going back to our question, we've got AD is equal to 15. Now remember, the line just means divided by, and our cos 30, our exact value for cos 30 is root 3 over 2. And we're dividing, so dividing fractions, you keep the first one, change the sign from a divide to a multiply, and flip the second. Now we can just multiply straight across, so 15 times 2 is 30. 1 times root 3 is just root 3. So we're almost there. It's still not the same as what they have. But the difference is we have got a root 3 on the bottom. And how do we get rid of the root 3 on the bottom? We need to rationalize the denominator. So I'm going to multiply top and bottom by root 3. So this gets rid of the square root on the bottom. So on the top I've got 30 times root 3. On the bottom I've got root 3 times root 3. Root 3 times root 3, well 3 3's are 9, so that's root 9. And the square root of 9 is 3. And then we can simplify our fraction. 30 divided by 3 is 10. So I end up with 10 root 3 as required. So there's a lot going on in that question. And the important thing is to make sure that you know these exact values for cos, sine, tan of 30, 45, and 60. So look, if you have any questions about part B, just let me know. It's worth 3 marks, and there's quite a lot there for 3 marks. You get a mark just to kind of show you where these marks are coming from. You get a mark for setting up the correct formula. And you actually get a mark for saying cos 30 anywhere. That's 2 of your marks without having to do any of this difficult stuff. And it's a 3-mark question, so even if you just write this down, you're getting 2 marks, which is good. You get your final mark for recognizing that cos of 30 is root 3 over 2, and getting it into this form of 10 root 3 by rationalizing the denominator. So although this question looks pretty difficult, you can pick up 2 marks just by simple trigonometry. Okay, going on to the last part of this question. We have to find the angle DAE. So DAE to the nearest degree. And we know that, okay, so this is 15. We worked out that, I just go back, AD is 10 root 3. Just make sure I read that correct. So AD, this is 10 root 3. And we need to work out this angle. So again, I'm going to draw a sketch of it, which is what I recommend you do in the actual exam as well. So here we go. We've got A, this is the angle we want to find. This is 10 root 3. This is D, which is a right angle triangle. This is 20, and this is E. And I've got 2 sides and an angle, so I'm going to use, and it's a right angle triangle, so I'm going to use trigonometry again. So I'm going to label my triangle. So this is the opposite, because it's opposite the angle I want to find. This is my hypotenuse, because it's opposite the right angle. So the other side is the adjacent. Thinking of our SOHCAHTOA, I've got the opposite and adjacent. So I'm going to use tan. And again, the formula is given to you in the formula booklet, but it's tan of the angle, which is, let's call it just A. Tan of A is equal to opposite over adjacent, 20 over 10 root 3. And if I want to find the angle, I need to get rid of the tan, so I need to do inverse tan of 20 over 10 root 3. And this is something I can put straight into my calculator, just as exactly as we see it. So inverse tan, there are 20 divided by 10 and our root button, root 3, and we get 49.1, and we want it to the nearest degree, so it's going to be 49 degrees. So even if you did not answer part B, okay, even if you could not do this, you should be able to get most of the marks for it. You can still do this part because they give you this side length, okay? And they give you this side length so you can work out this angle just by using trig. If you have any questions about question 3, just give me a shout. Happy to help.